Hello and welcome to Electronics. My name is Fatma Garba Yusuf, and today we are going to talk about classes, properties, and characteristics of materials. First, we're going to start with classes of materials. So here we have the traditional classes of materials are number 1 metals, number 2 polymers, and number 3 ceramics. But then these can be expanded or subdivided to include composites, nanomaterials, glasses, elastomers, and so on and so forth. In fact, metals can be further subdivided to give ferrous metals and non-ferrous metals, that is, metals that contain iron and those that do not contain iron. As for composites, they refer to a class of material that can be said to be secondary because it consists of at least two or more of the primary classes of materials fused together in one way or the other. For example, if you have a metallic table with wooden legs, something like that. And then nanomaterials are an advancement of the traditional materials, where they are usually characterized by very tiny sizes, and they have been used to achieve a lot of new tasks and develop novel technologies across the years. As for glasses, they are a subdivision of ceramics, and we know most of them. They are used to produce our glass containers, mirrors, and so on and so forth. As for elastomers, they can be said to be a subdivision of possibly polymers. As polymers, among polymers, there are some that are elastic and others that are inelastic. Meanwhile, this can be further explained by this figure below, which is a materials 3, because it shows the different classes of materials and their subdivisions as well as examples. For example, on the metals, we have ferrous alloys, aluminium alloys, copper alloys, and we also have pure metals, of course. Alloys can be said to be a fusion of two or more pure metals, and it differs from composites because in composites you're actually fusing two different materials, two different classes of materials, while in alloys you are fusing two different types of metals. So among our ferrous alloys, we have steels and cast irons. As for aluminium alloys, copper alloy, they refer to alloys that contain the aforementioned metal. Then we also have ceramics, and ceramics have been distinguished because of their strength, even though they are quite brittle. And there are traditional ceramics and also engineering ceramics. Engineering ceramics are, of course, the ceramics that were developed due to one reason or the other, while the traditional ceramics are the stone, the porcelain, those, earthenware that our forefathers used to produce. Then we also have polymers, and they can be subdivided into thermosets, which do not get easily destroyed, and they are quite strong, and thermoplastics such as polyethylene that are used to produce our nylon, such as polyethylene that are used to produce all these PET bottles that are used in packaging, and then nylon. Then, of course, there are elastomers such as the nitrile rubber, the silicone rubber, and so on and so forth. Then, of course, we already mentioned composites, and they are subdivided into metal matrix composites, which have like the metal as the main component, and we have polymer matrix composites as well as ceramic matrix composites. So if we were to expand our thoughts, we'll see that, of course, materials can be showcased in this figure here, because you can either add polymers to metals to give you composites, or ceramics to glasses, or elastomers to polymers, and so on and so forth. In any case, composites can accommodate these different classes of materials. Next, we are going to talk about our properties of materials, and we're going to look at them in different categories. So here we have the properties of materials may be categorized into, actually there are about 6 categories. There are physical properties, chemical properties, optical, magnetic, mechanical, thermal properties. So here we're going to look at each of them and have a brief discussion or list out some examples. So first we have physical properties of materials. So each material, even when you don't analyze it in a lab or anything, you can be able to deduce some properties that can be seen physically, such as the mass of the material, the density, its texture, how it feels, and of course its melting or boiling point. And also have chemical properties, which include the chemical stability, how reactive it is, flammability, does it easily gets ignited or burned, there's toxicity, is it dangerous, is it poisonous, there's heat of combustion. So these properties actually help in categorizing materials and also selecting the perfect job or perfect work that can be done with those materials. Next we have mechanical properties, and these are usually ascertained using a number of tests such as the hardness test and so on and so forth. They are used to analyze, they are mostly used in engineering because they usually help us to determine the kind of function that will fit any type of material. So they include hardness, ductility, does it stretch, the strength, does it break easily, elasticity, does it is it elastic or is it not elastic. We also have thermal properties, and thermal properties, as the name implies, refers to those properties that are related to heat or thermal energy. So we have heat capacity, the thermal stress, we have thermal expansion, how a material may expand under the application of heat. We also have thermal conductivity. This shows us whether a material can be able to conduct heat or not. And this will help us to know whether we can use it as a conductor in an application that needs conductors, or if it doesn't conduct electricity, we can use it as an insulator. We also have optical properties, and these are mostly characteristics of glasses or ceramics, and they include the reflectance or reflection, the transmittance of light, the refractive index, the emittance, and so on and so forth. Finally, we have the magnetic properties, and they include the magnetic intensity, the coercivity, the magnetic susceptibility, and of course the intensity of magnetization. So it'll be a good idea if you can check up or make further research on all these terms, as this is just an overview of all these properties. So I'm going to round up this video by talking about some characteristic properties of the different classes of materials. The first we have is metal. The class of metals has some characteristic properties, even though it's not all of them that have the same properties, but mostly metals are characterized by hardness, ductility, thermal conductivity, and even electrical conductivity. As for polymers, they are usually soft and flexible, and then because they are quite diverse and they are usually produced using organic materials, they have a lot of variable properties. While ceramics are typically very hard and of course very brittle, and this is why most ceramic products break on the application of a stress or on falling or on being dropped on the floor or something like that. And because they do not conduct electricity or heat, they are usually used as insulators. And then a very good property that ceramics have is that they have higher resistance to corrosion than metals especially. So with this, we've come to the end of this video. You can watch the subsequent video so that you can see how we can actually identify these different classes of materials right from a stress strain graph without being told, even though you might not be able to identify the actual material, but you'll be able to determine whether it's a metal or a ceramic or a polymer. So see you in the next video. Thank you for watching.